Thank you so much for having me here today. Thank you for allowing me to speak as well. I just realized that it's been a little bit over 2 years since I actually got up in front of an audience and gave a live presentation. I've been doing Zoom presentations for the past 2 years, and I'm frankly a little happy that I don't have to do that as the only one alternative anymore. So today we're going to be talking about a new type of image decorating technology called Signite. And Signite has, the genesis of Signite originated originally as a patent that a company called New Label Technologies filed back in 2017. Mid-2018, New Label Technologies, based up in East Providence, Rhode Island, was acquired by Actiga North America. This will give you a little bit of a genesis behind the technology that we've been working on now for the past almost 4 years. So in this presentation, what I'm going to be doing is talking to you firstly about, with two or three slides, who Actiga and Altana are. Then I'm going to be talking to you a little bit about what is Signite, what does it actually do. I then have a video that you can actually find on our website that goes through the printing process itself as well as the transfer imaging process of Signite, so that you understand a bit more about what we're actually doing here. If you haven't already seen it, there are a few people in the room probably who've seen it several times. Then we're going to be talking about our roadmap for technological development for this technology, specifically in the glass industry. Then I'm going to be giving you a really brief hardware overview to show you that yes, we really do have equipment and that we're just not a bunch of nerds sitting in a garage someplace in Rhode Island tinkering around. Then I'm going to be talking about some of the value propositions of this technology versus a few of the incumbent existing technologies out there for glass container decorating. And then I'm going to talk a little bit about our performance attributes as well as our quality program for this technology as we roll it out into the market. So very quickly, Actiga is one of 4 sister companies under the Altana umbrella. Altana is headquartered in Germany. Our company is also headquartered in Germany. Sister companies, BIC Chemie is a specialty manufacturer of specialty additives, let's say for anti-foaming, to basically improve flow and leveling of inks and coatings, that is well known within the chemical industry. We also have another sister company that's relevant to Signite, which is Eckhart Pigments. Eckhart is located in Painesville, Ohio. They specialize in metallic flake pigments, so they actually make golds and silvers in varying colors thereof that are used quite widely, not only in North America, but also on a global basis. So it's kind of a little strange that, at least for Eckhart, many of their customers are Actiga's competitors. So they sell their metallic pigments to companies like Sun Chemical, Flint, Seekwork, so on and so forth. But they're very well known for their metallic pigment technology in the marketplace. Actiga is, we are the new technology incubator, the Signite people operating within Actiga. Actiga also in North America is a major manufacturer of flexographic inks. So these are inks that are used for printing labels, as well as primer coatings, top coatings that are used in consumer product packaging, as well as adhesives and sealing compounds. So we also have a division that specializes in sealants that are used on the inside of things such as two-piece aluminum cans as well as monoblock aluminum cans. On a global basis, we have footprint not only in Europe and Germany, but also in South America, in Brazil, as well as in China. Notice that we don't have any footprint in Eastern Europe, which is kind of a good thing. Unfortunately, at the moment, it's kind of a good thing. Okay, so Signite decorating. As I mentioned before, this is a technology that we've been developing now for well over 3 years. Our initial focus in this journey was to develop an extremely thin image technology that you could apply to plastics such as PET. There's a big need for improving the overall recyclability, for example, of PET water bottles, not only in Europe but also in the United States. And so our idea was we'd come up with this excruciatingly thin image that you could transfer off of a carrier film onto PET bottles that would be a no-look type of image that you then basically, once that water bottle is used and it goes back to a municipal recycling facility, it could be much more easily detectable by the infrared systems that they use for recycling plastic. But lo and behold, we found out that water bottles are very thin and very difficult to apply anything to. So we decided to pivot to glass for the short term because it's it's easier to transfer an image over to glass because it's extremely rigid. Most of the cooling and coatings on glass are well known in the market, the chemistries. So it's a lot easier to formulate around something that's known than something that is flexible, as well as could have slip aids, as well as even silicones on the outside of it. So this technology that we've developed, it's 100% photopolymer based. So photopolymer chemistry means that it's cured either via UV LED, or even low energy electron beam. UV basically is a wavelength or a spectrum of light. With UV chemistry, you basically have monomers, oligomers, and you have photoinitiators. The photoinitiators are catalysts that set off, such as, it's the same chemistry that's used in UV screen printing, where you see that light that's being used to cure the chemistry. We use the same type of chemistry. So basically, the way that we look at the chemistry, we can dial in or dial out the need of, or the goodness of fit for the application based on the type of ingredients that we use. So we know that most all of our ingredients are indirect food contact compliant or very benign if you're going to be touching this chemistry with your hand once it's been cured. At the moment, we are focusing on cylindrical flat wall containers with this chemistry, or with this technology. Pretty soon we'll be getting into other types of morphologies, shapes, asymmetric shapes, squares, blocks, flexible things, but we really haven't gotten there yet. I'll talk a bit more about that in a few slides. So what are the environmental benefits of Signite decorating? Significantly, and that really depends on what you compare it to, right? So if you compare Signite decorating to, let's say, pressure-sensitive labels, we're not printing onto a phase stock. And typically with pressure-sensitive labels, you have a carrier film, and then you have either a plastic or a paper-based phase stock that's stacked on top of that. We don't require that with our technology. So in essence, what we're doing is drastically reducing, versus pressure sensitive, the amount of material that's required in order to transfer an image onto a container. So we've got a significant reduction in the amount of material that's actually used. In addition, we don't need to print in blocks. We can print really any way we want to with our technology because it's a hybrid digital technology. So we can print only the essential elements that are in the design, and we can rely on basically either what's in the bottle or other methods in order to reduce the amount of material that's being placed onto the glass. Glass container recycling and reusability, before the pandemic, no one really cared about reusing glass bottles. All of a sudden now in North America, there now is a lot more of an interest in how do you actually keep glass containers out of landfills. And then hopefully with the transportation of the federal bill here pretty soon, you'll see a lot more municipal recyclers of glass than ever before in the past in North America. If you take a look at North America, the United States specifically, versus Europe with regard to how much glass is actually recycled, I think it's at least 2 to 3 times more in Europe, depending on the country, versus in the United States. In the US today, I think that the actual recycling of glass is well less than 20%, which is kind of a shame. If you think about how much energy is used in making glass and how much energy is used in transporting glass around, and then finding out that a lot of it goes into the landfills, it's kind of a shame. So with this technology, the way that we have developed it, hopefully in the near future, we'll be able to come out with claims such as you can more efficiently reuse glass with this technology because it is easy to remove from the glass, or because it can be easily detected by a sorting system so that you don't have to worry about mixing your colors of glass anymore. You could actually make the technology or the label itself smart in order to tell the sorting system where the glass should go. Lower carbon footprint, it's anticipated. During the course of the next year, we will be doing a life cycle assessment on the carbon footprint of this technology, starting off with versus pressure-sensitive labels. We assume that the technology is going to be lower in carbon footprint versus pressure-sensitive, simply because we don't have a phase stock in our printing process. But what we'd like over the course of the next 2 to 3 years to also be able to measure the total carbon footprint of this technology versus that of screen printing on both sides of the fence, UV as well as ACL, and then also direct-to-object printing. There's very little information at the moment with regard to many of these printing technologies out there in the marketplace regarding carbon footprint, but very quickly here, probably over the next 2 years, you'll have a lot more brands asking for this data because they'll have their own duty owed to the market to basically talk about how much carbon each of their products generates. And then there's also going to be a boatload of legislation coming down the pike here pretty soon around extended producer responsibility, where, for example, if you're a candle manufacturer and you've got a candle that you've printed on, if you ship that candle into the state of, for example, Maine, or pretty soon here probably California, you might get taxed on the end of life of that candle if you can't demonstrate that that candle actually can be, in some way, shape, or form, recycled. So pretty significant, monumental changes coming up here pretty soon in the landscape for consumer products and how they're handled end of life. So what are some of the characteristics of Signite printing technology? The way that we print this product, we can match colors with less than 1 delta E in variance, which is pretty significant. We're using the latest print technology that's available to the market. We use a P7 Mark Andy hybrid digital press to do this with the latest software imaging technology. Typically, the human eye it's very difficult for a human eye to detect at least 1 delta E between 2 colors that are sitting next to each other. We have the ability to print in registration down to 3/1000ths of an inch. So the way that we lay our technology up, one stacked on top of the other, it's becoming very difficult to discern the difference in the layers of our technology versus what you currently see out in the market, which is important as well. Our print capability, we are now up to 1200 DPI with regard to image resolution. Typically, the human eye cannot see over about 300 DPI, so our printing technology now basically has the ability to print full image, photographic quality imagery. We use true metallics from Eckhart Pigments. In a way, we cannot print at the moment chromic metallics. That's just not what our metallics will do at the moment. Hopefully in the soon future, within the next 3 to 4 years, we will be able to print chromic metallics that you see today out in the marketplace with ACL, and I think in certain cases also UV screen printing. But there's a benefit to that. The way that we print our metallics, basically there's not a lot of waste. There really isn't any waste at all. With cold foil applications, there's a significant amount of waste that's generated and basically getting metallic into that image process. Our surface finishes are different. We don't really use additives in the way that we create surface finishes. We print all of our chemistry onto an ablated film. So we basically ablate the film based on the type of look that we want on the surface. So if we want a matte look, we'll have a certain type of ablation. If we want a high gloss, we will have a much lower amount of ablation onto that casted film. If we want a holograph in our image, we'll be able to make sure that the carrier film has holographic images embedded in it, so that once we cast our chemistry and cure it and then release it, you'll have holographics. Pretty soon here, we'll also be able to create topographies or haptics using software technology, building that into how the chemistry is applied to the surface of the carrier film too. Okay, opacity is basically how we manage the usage of whites. So we have whites that are either piezo digitally applied. Piezo digitally applied whites typically use particle size distributions that are much higher than basically flexigraphically applying a white. So digitally applying a light will give you a higher opacity than flexigraphically printing one, because you have a thicker layer of that white, which basically obfuscates transparency. This is my video. I think I'm only going to probably play the first minute and a half of the video. The purpose of this video is basically to show you what this looks like when it's being printed on press, and then what it looks like when it's being transferred and applied to an article. So I am going to click here and hope it works. Because this is a hybrid technology, we do have to use photographic plates on the front end and on the back end of the press. The plate on the front end is to lay down the trigger image or the clear coating. The plate on the back side is used to apply the adhesive. So the press that we can use can print at well over 200 feet per minute, most any image. And this is our application system. This is how we're transferring that very thin image over to containers. So it's really actually pressed onto the container, pressed and then rolled on, as opposed to having the label flailing out there waiting for something to pass by it. Oops. Okay, next, the roadmap. So our current year roadmap, really we've decided to slow down a bit. As I was saying before, 2.5 years ago, we were trying to figure out how to take this technology and apply it not only to glass, but also to plastic articles, as well as over to aluminum-shaped rigid packaging and semi-rigid packaging. We've decided to slow down a bit and focus simply on, at the moment, cylindrical objects that are flat-walled. We're really trying to create ecosystems around North America where we find a glass decoration house. We basically enable them with the technology. We will supply the hardware equipment to them for X period of time to get them up and running and familiar with the technology. And so that they then can go out and populate, samples and get customers running on this. It's been a really hard 2 years. It's been extremely difficult to get interest on this technology. With craft spirits, the wine industry, the beer industry, everyone has been really just struggling to keep their doors open and their businesses alive. We're just now starting to see folks interested in the technology. We were also looking at certain specialty beverage applications where they're packing out their products in glass containers. The candle market for us has been a very interesting market for a couple of different reasons. And then we're also looking at a few adjacencies that really wouldn't be relevant at the moment to talk about. Moving forward into the future, in 23, we're hoping that by then we currently do have a prototype that can transfer images over to a tapered container shape, but we'd like to do a bit more R&D on that before we release that commercially into the market. We're hoping that by the end of 2023, 2024, we'll have a system that will be able to address asymmetric shapes, tapered shapes with this technology. We're hoping also pretty soon here in certain specific applications that we can start using this technology as a replacement for shrink sleeves for flexible aluminum two-piece cans where the can has already been filled and seamed. But that in itself is kind of a small market. We're doing that because we know that there is pending legislation in various areas around North America around single-use plastics. In the province of Quebec, as well as now in California, it looks like single-use plastics are going to be curtailed in how you can actually use them in the market unless you can actually prove that they can be recycled, which is really hard to do. Okay, so the applicator system itself, it's not very large. We're talking about a system that's about 6 feet in total length, and it's about 5.5 feet wide. It operates off of 110 volt. This system in itself will be able to decorate up to about 50 750 milliliter cylindrical wine bottles on a per minute basis. It's a very compact system. We have everything is programmable. You can put in your recipes, tell the system exactly what type of bottle you're going to be decorating, how many you'd like to throughput on a per minute basis, and it basically will go ahead and do that for you. This is more or less what the system looks like if you're taking a much closer look at it from the application zone as well as from the containers that are coming out of a flame treatment cell into the inline decorator. All of our technology requires, at least for glass, flame treatment. We found that with photopolymer UV curable adhesives, if you excite the glass, if you can get the cooling coating on the outside of the glass up to about 140 degrees F, that typically is the perfect Goldilocks zone for getting good adhesion and transfer of the Signite image off of the carrier film and mechanically bond it, if you will, to the surface of the glass. We are working on modifications to the chemistry that will not require heating the cold-end coating. But that might take us some time in order to fully develop and commercialize, but it's part of the roadmap as well. There's no pyrosil that's needed for this system. There's no primer coatings that need to be placed down first. It really is the UV adhesive that does most of the magic in conjunction with slightly heating up the cold-end coating. So in the next, there we go. So this is basically showing you the bottles being propelled through the applicator, and there is that pad on the left-hand side that has the image sitting there waiting for the bottle to pass by it. This is a photo of our flame treatment system. The flame treatment system is a series of 4 heads. We have a small baffle here. Once the containers, they run past the first flame treater, they'll hit the baffle, and that baffle will rotate the bottle so that we get a 360 application of flame onto the containers before the containers run through the hardware applicator. We are now integrating these flame treatment systems onto the inline hardware applicators because we have integrated the system so that we know that with every bottle that runs through this, it will have perfect flame treatment, and it'll be basically sequenced with the applicator system so that you won't have traffic jams, if you will, of bottles. So we're really sending out all of our systems now with both the flame treatment, highly recommended, along with the applicator to customers that are interested in the technology. I'm sure you've all seen a flame treater before. So the value proposition for this technology, if you take a look at Signite and the way that we print this and apply this to glass, we're getting, if we want, an extremely high resolution photographic quality image, which is kind of hard to do with screen printing. The opacity level that we're getting on this process now is reaching that of a UV screen printing process. We now have the ability to print full Pantone colors with this technology, so it's not simply 1 or 2 colors. We can print a whole cacophony of different colors and then transfer them onto containers. We don't have any issues with color matching because for us that's all done with the hybrid digital press and the technology, the software technology that's in the press. No need here for making screens. We do have to make plates on the front and the back end of the press. Plate making is typically about a 24-hour turnaround time. Really doesn't cost that much money these days to make plates. And they can be done locally too. There's no cleanup with this. If you were to have one of our inline hardware applicators at your facility, basically we're printing the technology for you and then we're shipping it to you overnight. Typically our turnaround times are less than a few days for what you need. Other value proposition points here versus UV screen printing. We know that it's very difficult to print screen printing 130 or 360 degrees around a container. That's not a problem with us. We can do full wrap designs with our technology. As I mentioned before, we have metallics. We have hundreds of different permutations of the color we can get with our metallics. We can achieve full matte finishes. And basically our minimum print run for this technology is 1 as opposed to a few hundred because we're using hybrid digital technology. Another nice thing about this is that once we print our rolls, there's no post-curing that's typically required with UV screen printing. Once it's printed, it's cured, so you don't have to let it sit someplace and post-cure overnight. Once our rolls are printed, they're ready to ship within about an hour or two, as soon as we can get the FedEx guy to pick them up. If you take a look at our technology versus ACL screen printing, we believe that just from the energy that's used with ACL versus our technology alone, we believe that our technology is a game changer for someone that is looking for something that is screen printed that has semi-durability to it versus going out and buying a Lear oven and all of the energy that typically is used in running a Lear oven versus our value proposition for printing this technology. And then additionally, much better utilization of implant floor space, and then carbon footprint, as I just mentioned, goes down tremendously. Against pressure-sensitive labeling, our technology enables a no-look 360-degree wrap design, which is at times very difficult to do with pressure-sensitive labeling. And once again, we're significantly reducing the amount of material that typically is being used versus pressure-sensitive labeling. Our technology doesn't require any type of die cutting or lamination. That's really built into the additive printing process that we've developed in manufacturing the image. Print quality. Performance. Basically, we do a tremendous amount of testing with regard to solvent resistance, scratch and abrasion resistance. We have a shaker table within our lab, so we test for transportation resilience. We do that for a number of reasons because of a few of the brands that we work with that are in the beverage space. We do an enormous amount of work with regard to how much resilience does this image have if you were to immerse it in an ice bath for several days. That's really important, for example, in the wine industry for tasting rooms, where you might open up a bottle of wine, you're sitting it down in a glass bucket, and you want to make sure that the label is not going to pop off of the glass container after a few hours. So we do a lot of that work in-house. We also have gone out and bought a bottle washing system, and we also test basically how long our labels will stay on our images will stay on the outside of a container if the inside of that container has to be washed out. So we do a lot of testing with that too. We have also baked our images for multiple hours at extremely high temperatures, just to make sure that the chemistry is not starting to chemically unzip, starting to yellow, or starting to crack, or starting to do any other funky things that we don't want it to do to replicate. Number one, what's going to happen if this decoration ends up on the outside of a glass candle container and it has wax in it, and let's say that container is going down a wax filling line. So we want to make sure that the imagery isn't being degraded because of the amount of heat that is coming into contact with. Oops, that's not what I wanted. Quality program. We send out, at the moment we're sending out proofs of everything that we do. When we send out proofs, it's pretty quick. It takes only maybe 2 or 3 hours to do so once we have our plates in place. And we do this because we want to make sure the customer understands is the color right? Is this the right look? Because we can show you in an AI file what it might look like, but it really doesn't hit the road until you actually see a prototype of what this technology is going to look like on a container. So we do a lot of shipping of prototypes out to customers before they place their orders. We also have 100% vision inspection on everything that we do to make sure that we haven't made any goof ups in the transfer process of the image off of the carrier film and onto the container. We've gotten our defect rate down to less than 1%, and we assure that before we ship. We also will not ship any roll that's less than 1,000 linear feet, so that you're not stuck constantly, switching out rolls. And then we have a lot of other customer-specific in-house quality program details that we write in based on what the customer needs are as well. That's really the end of my presentation. Hopefully you got a small glimmering of what we're talking about when we talk Signite, and what the technology potentially could currently avail or help the glass decorating industry with, and then hopefully where we can be taking this technology in the near future. So thanks for your time.